Welcome to my next video on vector databases. I'm going to provide you an introductory session about vector databases. I will tell about what is vector database, how is it used, where is it used with a few use cases. I will cover all them in 5 minutes of time. And this will be helpful for you for your further learning on vector databases in AI and ML space. We already have multiple number of database types: relational databases, non-relational databases, commercial off-the-shelf databases. Then why we need these special vector databases? We know every database store, manage the data. This particular vector database used to store and manage very complex unstructured data, all in a single place. The unstructured data can be a text, volume of textual information, either PDF, Word document, or anything like that. You can store images of different types, right from JPEG to PNG to BMP. And you can store audio files also. So these are unstructured data stored in a single database, and you can still query the database in a very meaningful way. That is, it helps in semantic CH rather than exact keywords. I will briefly explain you the difference between semantic CH and the and the regular exact keyword CH in subsequent slides with an example. Now, if you see the traditional database, you have either RDBMS or NoSQL, and what they can do is they can store the data, manage the data. When you do a CH inside the database, it follows exact match CH operation. That is, it CH the data very perfectly. However, vector databases which follows similarity CH or a kind of semantic CH. For example, in traditional databases, which works mostly on the structured data, in some cases unstructured data, where you can ch a string, and if there is a match found, you can retrieve the associated record or records. Whereas vector database works on most of the time on the unstructured data. It follows semantic or meaningful data. Say for example, in traditional database, if you are looking for a keyword dog, it bring up the record where the matches are found against a particular column or columns where the ch string dog exists. Whereas in vector databases, which works on unstructured data, brings up all the records which matches the keyword dog plus other meaningful records, something like pet animal, pet, puppy, all are semantically equal to the ch keyword called dog. So that makes a difference between traditional database and the vector database. Here you could see how the semantic database ch works. Let's see how the vector database is built. On the left, you have source data, which may be either a Word document, or it can be a movie, or an audio, or an image. Using an embedding service, we can transform this data it into an embedding. So embedding works by converting raw data like this text, image, audio, it into a dense numerical vectors that preserve meaning and the relationship between the data. First, the input is processed through a model such as transformer for a text or a CNN for images to extract the key features. These features are all encoded it into fixed length vectors like whatever you see here, which are high dimensional space where similar items are positioned close to each other. Something like this. Dog and puppy are close to each other. These are the image files and these are the other set of files. So these are positioned close to each other and dissimilar items further apart. This spatial arrangement allows similarity to be measured mathematically by enabling application like CH, recommendation, and classification to operate based upon meaning rather than exact match. So in vector database, these source data are all stored in such a way that they are close to each other in a vector data format like these binary strings. So they are logically grouped and the distance are matter. So when you ch a particular string, it also mathematically looks for the nearby items and also they will be produced as a result. That's a fundamental concept behind vector database. Now let's see vector database, how it is helpful for building a knowledge base and how it helps in accessing LLM and improve our query case. Assume you are a user, you are writing a prompt, something like summarize our latest market analysis. And this will be fed as an input through your application. And it goes and look for vector ch to the vector database. We have already seen the vector database is built using vector embeddings, collection of strings of collection of strings of zeros and ones. And these are all grouped in such a way that when you do a ch, it return a semantic or meaningful result. We have already seen this vector database is composed of various document, structured and unstructured data. It also gathered various information. Say for example, in this particular case, it is related to market analysis. The market analysis will be analyzed through a vector database that contain proprietary information about the market, structured data for a set of companies, and the APIs that pull the information from various external sources, all will be embedded and converted it into vector embeddings and put up there in the vector database. And when your query hits this vector ch, the result will be retrieved as a context. When this context along with your prompt fed as an input, that is prompt plus context, which will be a perfect augmented prompt. And when it is used by your large language model, you will get a most accurate or meaningful response from the LLM. That is, the hallucination effect will be reduced. This is how your vector database fit in and works with your LLM. Now let's see what are the different types of database which comes under broad spectrum of vector databases. Like relational databases or non-relational databases, vector database is a paradigm that has a different types of databases. And the most popular among them is the ChromaDB. ChromaDB is a lightweight, developer-friendly vector database often used in LLM-powered applications, like the one whatever I have shown in the previous slide. The next choice by the developer is Pinecone. It's fully managed cloud-native vector database with high scalability and low latency CH, and loved by most of the cloud programmer or cloud application. Next come, it is called Weaviate. It's again an open source. It supports for both hybrid, that is keyword plus vector ch, and offers built-in machine learning modules within inside that. And the next one is Milvus. It's again a highly scalable open source database optimized for large scaled similarity ch. It's extensively used in PDF parsing, embedding, and ch. And the last one is Quadrant. It's again an open source, focus on high recall, performance, and easy of integration with any AI application. So if you see here, most of the database under vector database are all open source software. So depending upon the nature of the application or type of the application, you can choose any one among them and use it for your application design and development. Next let's see very brief about how the vector database is used. And this list is limited, and there are multiple user scenarios are there. Say for example, in RAG, the most prominent use case using a vector database is just help the LLM with the external proprietary or real-time data, like the one whatever we have seen in the slide couple of slides back. So it prepares a context for your LLM. Context with the prompt, when it fed is an input, it reduces the hallucination. And the next it helps in the semantic and hybrid ch. So traditional keyboard ch fails when user misspell words or use synonyms or describe intent. Say for example, if dog is misspelled as DUG, then it is a misspelled information. So in that case, semantic and hybrid sketch where you can use vector databases. Next one, recommendation systems. For example, in e-commerce or in media or in social relay of understanding user preferences, you can use vector databases. The fourth one is in the area of image and multimodal ch, where you can use vector database which do not just index the text. They can also process multidimensional data like images and videos put together and provide you a comprehensive search result. Fifth one, AI agent memory. Nowadays, in modern AI application, act as an autonomous agent that learn over long sessions. And over a period of time, they act as a agent which is very intelligent and will provide more accurate results. The sixth one is related to semantic catching. Here, when you make a repeated calls to a large language model, API can slow and it will be a more expensive one. If you use a vector database, semantic catching can helpful to improve the performance of the application and also less expensive compared to use direct APIs to your LLM. And the last one is anomaly detection. Here vectors are all highly effective and at capturing the required result with more easiness. So these are the some of the potential use cases where you can use vector databases. I will be picking up each and every use case of this and expand it with the related technology stack and provide you live demo in the succeeding sessions. I hope this session is helpful to you for your journey towards AI and ML. And stay in touch for the next update. Till then, thank you and take care of you. Bye.